Today we will discuss polynomials, the polynomial chapter, which is chapter number 2. So a polynomial is an algebraic expression where exponents of the variables are whole numbers only. You see, suppose we are taking an example. Let p of x denotes the polynomial. p of x एक polynomial है जो सब एक्स स्क्वायर let it be minus 8x plus 12. Now this is the polynomial is having three terms. The term one is x square and another one is minus 8x and another is 12. Three terms. And here variable is the x, variable is x, and here the exponents are, for first term exponent is 2, for the second term exponent is 1, and for the third term exponent is 0. And here all these exponents are whole numbers. Whole numbers means the numbers ranging from 0 to infinite. 0, 1, 2, like this. And in class 9 we have studied that हम ये पढ़े थे कि अगर 1/x minus 1 होगा तो it will not be a polynomial. It will not be a polynomial. Why? Because this can be written as x minus 1 whole to the power minus 1. This minus 1 is not a whole number. Similarly, root x, it cannot be a polynomial. Not a polynomial. Because here x is having power 1/2, which is a rational number. It is not a whole number. So it cannot be a polynomial. And here in this chapter, we will generally concentrate on second degree polynomial. That means the highest power of the polynomial will be equal to 2. Here, degree of this polynomial px, here the degree of px, what we have taken here this example, इसका मैक्सिमम पावर जो है x का ये 2 है. सो डिग्री ऑफ दिस पॉलिनोमियल इज 2 हियर. सपोज फॉर एग्जांपल वी विल टेक ए पॉलिनोमियल इज x क्यूब प्लस 2x स्क्वायर प्लस 3x प्लस 6. हियर द डिग्री इज 3. Here the degree is 3 because the highest power of the variable is 3. So the highest power of the variable determines the degree of the polynomial. Next is value of px at x is equal to k. The example we have taken, that is x square minus 8x, ये हम लिए थे, that is equal to p of x. Suppose at x is equal to 1, if you put x is equal to 1, so p of 1, then we have to put 1 in place of x. x के जगह में हमको 1 पुट करना होगा. 1 स्क्वायर minus 8 into 1 plus 12. अगर हम इसको सिंप्लीफाई करेंगे ये हो जाएगा आपका 1 minus 8 plus 12. So this will equal 13 minus 8, which is equal to 5. That means 5 is the value of p of x at x is equal to 1. So we can write the value of p of x at x is equal to a is equal to p of a. So here the value of p of x at x is at age x is equal to 1, x is equal to a, here a is 1, that is equal to p of 1 which is equal to 5. That means we have to put the value of a in place of x, then we will get the value of px at x is equal to a. Similarly, at x is equal to k, we have to put the value of x is equal to k, right? Now zeros of the polynomial, we will again take that p of x is equal to x square minus 8x plus 12, suppose. For this example, if we put x is equal to 2, then p of 2 will be equal to 2 square minus 8 into 2 plus 12. So this will be equal to 4 minus 16 plus 12. So this will be equal to 0. So hence the value of x is equal to 2 is the 0 of the polynomial. So value of x for which px becomes 0 is called zero of the polynomial. Hence 2 is the 0 of px. Here hence two is the 0 of p of x. Now similarly, if we will take x is equal to 6, then we can write p of 6 will be equal to 6 square minus 8 into 6 plus 12, that is 36 minus 48 plus 12, which is equal to 0. So hence 6 is a 0 of the polynomial, 0 of p of x, right? That means to find out the zeros of the polynomial, we have to put p of x is equal to 0. How we will solve it, that we will discuss in the next slide. Now here check this question. If minus 4 is 0 of the polynomial p of x, then value of k is, it is already given that x is equal to minus 4 is the 0 of the polynomial. X is equal to minus 4 is the 0 of the polynomial, 0 of px. So what we will find, p of minus 4 will be equal to 0. If x is equal to k is the 0 of p of x, then p of k is equal to 0. Okay, that we studied just now. So you put, हमको अभी पुट करना पड़ेगा x इज इक्वल टू -4. सो p ऑफ -4 हम इसको लिख पाएंगे -4 होल स्क्वायर माइनस ऑफ, इन प्लेस ऑफ x वी विल रिप्लेस x बाय -4, -2 -2k. So this will be equal to 16 plus 4 minus 2 minus 2k, or this will be equal to 20 minus 2, that is 18 minus 2k. As p of -4 is equal to 0, then we will put this is equal to 0. or we can write 2k is equal to 18 or k is equal to 9. Okay, next is, this is one of the important concept, graphical meaning of p of x. Same example we have taken here. If we will take p of 2, we have already seen it is equal to 0. P of 6 we have taken it is equal to 0. That means p of 2 is equal to 0. That means we have to put 2 here, 2 square minus 8 into 2 plus 12, which is equal to 0. Okay. Similarly, if we will put 6, then 6 square is 36 minus 8 into 6 48 plus 12, which is also equal to 0. That means p of 2 and p of 6 will be equal to 0. And you see in the graph, we have taken these 2 points. One is here, p of 2 is 0 and p of 6 is 0. Now if you put x is equal to 4, you see x is equal to 4, then p of 4 take x is equal to 4. So p of 4 will be equal to 4 square minus 8 into 4 plus 12. That is 16 minus 32 plus 12, that is equal to minus 4. The point is this one, x is equal to 4 and y is equal to minus 4 is this point. Similarly, if we put x is equal to 1, then p of 1 will be equal to 1 square, it is 1 minus 8 into 1 8 plus 12, that is equal to 5. 13 minus 8, which is equal to 5. Similarly, x is equal to, if we will take 7, then p of 7 is equal to 5. You see here, if that is 7 square, you will write p of 7 means p of x is equal to 7 square minus 8 into 7 plus 12, that is p of 7. You will see it will be equal to 5. 49 plus 12, 61 minus 56, that is equal to 5. So point is here, 7 it is equal to 5. Similar to 1, it is equal to 5. Actually, if you will see, it is a symmetrical graph around this line. If you will see this line, if you will take, it is the value of this at x is equal to this, all will be same. You see, this value will be equal to this value. Okay, we will get a symmetrical graph. That in detail we will read in the higher classes. Okay, now the graphical meaning is that here it cuts how many times it cuts the x-axis, and in this case it cuts the x-axis at 2 points. One is 2 and another is 6. What is 2 and 6? 2 and 6 are the zeros of the polynomial. So you will see zeros of the polynomial is same as zeros of polynomial is equal to number of times the graph cuts x-axis. The graph cuts x-axis. Here the graph cuts the x-axis at 2 points. So it has this polynomial x square minus 8x plus 12 has 2 zeros. And fundamental theorem of algebra tells that if a polynomial p of x has degree n, then it has at most n number of zeros. Okay, we will understand it now. Here x square minus 8x plus 12, x square, this example, x square minus 8x is equal to 12 is the p of x. It has degree 2. It will intersect the x-axis at 2 points, maximum at 2 points, and here we have already seen that is it intersected the x-axis at 2 points. Then at most, what does it mean? At most means if the polynomial has degree 2, then in place of n you read it as 2. If a polynomial px has degree 2, then it has at most 2 roots. And what example we considered, जो example हम देखें इसमें maximum 2 zeros है. हम ऐसे एक example देखेंगे जहाँ पे number of zeros will be equal to 1. For example, we take x plus 4 whole square is equal to 0. Actually, this is x plus 4 whole square. Let it be the px first. Let the px is x plus 4 whole square. It will be equal to 0 when x will be equal to minus 4 only. You see. Actually, this is a quadratic polynomial. X square plus 8x plus 16. It is a quadratic polynomial. But it has only one root. That means 1 zeros. Sorry, in case of polynomial, we will consider this as zeros, where in case of quadratic equation, we will see it will be the roots of the quadratic equation. Same thing, the zeros of the polynomial is same as the roots of the quadratic equation. So x is equal to minus 4 is the only 0. You see here, x is equal to minus 4, that means the graph will be somewhat like this. That means it will touch the x-axis. Here, when it touches the x-axis, it has only one root, only one zero. When it touches the x-axis. When it intersects, the polynomial intersects the x-axis, the number of points it intersects. That means here the graph intersects at 2 points. So it has 2 roots. If the graph neither touches the x-axis nor it intersects the x-axis, then it has 0 roots. For example, if we consider this one, this curve does not touch or intersect the x-axis. Similarly, suppose you take this one, this is not touching the x-axis, so it has 0 root. It has 0 root or 0 zeros and not roots. Roots actually in case of the quadratic equation. In case of quadratic polynomial, the number of zeros we will call 0. Number of zeros is equal to 0. And in case of this also, number of zeros is equal to 0. Okay. Now x is equal to minus 4 is the only 0 here, because for x is equal to minus 4 p of x will be equal to 0. P of minus 4, if we will put this is equal to 0, this is the only 0 of this polynomial. Okay. Now consider this graph. Here graph of the polynomial p of x, this is the polynomial p of x. This graph, actually this graph is the polynomial of p of x, is given, and the number of zeros of p of x is how much, मतलब how many zeros are there, हमको कितना जीरो है वही फाइंड करना पड़ेगा. फर्स्ट वी हैव टू चेक this graph whether it cuts the x-axis or touches x-axis, or it neither touches nor intersects the x-axis. Here if you will observe, this graph cuts x-axis or intersects x-axis at these 2 points. So this polynomial p of x, इसका दो ही रूट होगा. जितना बार x axis को कट करेगा we will have that many number of roots. So here the number of roots will be equal to 2. So number of roots, number of zeros of p of x is equal to 2. Similarly here two polynomials are shown in the graph below. The number of distinct zeros both the polynomial is. Okay, the first is there are actually two graphs, two polynomials here. One is showing in this graph. You will see for this graph, suppose let this be a p of x or p1x, and another one is this one. Let this be p2x. p1x intersects the x-axis at these points. p1x we have taken it as red color, that is at this point and at this point. So p1x has 2 zeros. Similarly p2x, if we will see, we will have 2 zeros. P, because it cuts x-axis at 2 points, has 2 zeros. But these values of zeros are same for both the polynomials. Same zeros for p1x and p2x. Hence the number of zeros, it has been asking distinct zeros. Suppose this is equal to minus 3 and this is equal to suppose 4. Then p1 has zeros minus 3 and 4. p2x is also having the zeros minus 3 and 4. So distinct, there are no distinct zeros. The zeros are only minus 3 and 4. You cannot take it, write it 2 times. So number of distinct zeros of this both the polynomial is 2.